Okay, so we will move on to the next concept, that is what an ionic radius. Okay, ionic radius. Okay, here guys, ionic radius and atomic radius. These two were one and the same things. Here in ionic radius, we will have an ions. Okay, here guys, generally you know that there are two kinds of ions. One is what an cation, and the one is what anion. Okay. Here cation will consist of positive charge, whereas your anions will consist of negative charge. So how we will get the charge for an element? That is what our next question. Okay, if an element is there means if you guys were removing one electron from this element, removing of an electron is taken place, then the element will generate positive charge. Okay, if an element is there, if you remove an electron from this element means the element will have a positive charge. Whereas element is there, if you are adding an electron means to this element, you guys are adding an electron means this element will develop negative charge. Okay. Elements, removal of an electron develops positive charge. Elements, adding of an electron will develop negative charge. Okay, here guys, if negative positively charged element is developed means this is considered what? Considered as an cation. If the element will develop a negative charge means it will be considered as an anion. Okay, anion and cation. Okay, here then to measure an ionic radius, then again the same thing. It is what? And half of the distance between the ions in the crystal system. Okay, or crystal lattice. Okay, ionic radius is again what? Half of the distance between the ions in the crystal system. That is considered as a what? Ionic radius. Okay, ionic distance is means what? The distance between the ions in the crystal system. If you consider ionic distance by 2, that means you guys were dividing the distance between the ions in crystal system, then that will be called as an ionic radius. Okay. Here guys, if the ions were there in the crystal system means one should be an cation and another should be an anion. Okay. If these two were arranged in a crystal system, then half of the distance between these two is considered as an ionic radius. Half of the distance between these two is considered as an ionic radius. One is an cation, another one is an anion. Then these two were arranged in a crystal system. Then you have to measure the distance from the cation nucleus to an anionic nucleus. That will give us what? Ionic distance. Then half of the distance between these two is considered as an ionic radius. Okay, this is what how we will calculate ionic radius. And one more thing guys, again the variations of ionic radius I will consider. Variations of ionic radius. Okay, here guys, ionic radius means what? If the ion is cation, if the ion is cation, then its radius is less than parent ion or parent atom you should take. Okay, parent atom. For example, if I will consider a sodium atom. Okay, here ionic radius, if the ion is cation, then radius of this cation is less than the parent atom. Okay. Na is the sodium atom. This is called as what? A parent atom, and we removed an electron to form an cation. That is what? Na plus. Okay, this is what? Na plus, and this is what? A cation generated from your parent atom sodium. Parent atom sodium generates an sodium cation. Here you guys observe here, if the atom is converted to an cation, that means by using an electron it is converted to a cation means its radius will be less. Its radius will be less. Here sodium, it is having the radius of around 186 picometer. 186 picometer. Whereas in its Na plus cation, the radius should be what? Decreases to an 95 picometer. To an 95 picometer. Did you got this one, guys? Yeah. Sodium atom in its atomic state, that means there is no losing of electrons. The radius is around 186 picometer, whereas in sodium plus 1 and cation, that there its radius is only 95 picometer. That means and large variations of radius will take place when your parent atom will generate cation. Okay. If we consider a variation of ionic radius in an anion, if your ion is an anion, then the radius of your anion will more than your parent atom. Okay, compared to your parent atom, your anionic radius will be more. For example, if you consider a fluorine atom, and adding of electrons will take place to generate a negative charge on your fluorine atom. That is what here. This is what an anion. This is what an parent atom. Here its atomic radius is around 364 picometer, whereas in F minus, this is what an anion generated from the parent atom fluorine. This will have a radius of 136 picometer. Did you got this, guys? Look at the variations here. Ionic radius for cation. Radius of your cations would be less than your parent atom. That means sodium is a parent atom that will generate an cation Na plus by losing an electron. The radius of the ions is less than your parent atom. Here your parent atom atomic radius is around 186 picometer, whereas ionic radius is 95 picometer. Here come to your anionic part, ionic radius for your anion. That means the radius is more than the parent atom. If you consider a fluorine, this is what a parent atom. It will have an atomic radius of 64 picometer, whereas if it is converted to an F minus ion, that means an anion, an extra electron is adding out, so it will be converted to an anion. So its radius is increased from 64 to 136 picometer. Okay, this is what a variation you can observe. If positively charged ions were generating, the radius will be less than the parent atom. If negatively charged ions were generating, then the radius of this ion will be more than the parent atom. Okay, did you got this one now, guys? Here in the next part, why this anions will have a more radius compared to its parent atom. That is what a concept here. Ionic radius of your anion will be more than its parent atom. Because here, guys, we are adding an electrons to an atom, right? Your nucleus is there, and here previously present atoms consisting of an electron. To convert a neutral atom to an anionic part. That means what? Here a parent atom is converted into an anion. Here we has to add electrons to this atom. We have to add an electron to this atom means here already there is a presence of too many electrons in the atom, and this is also a negatively charged. Each electron is what? A negatively charged electrons, and you guys were adding one more electron to develop negative charge on the atom. To develop negative charge on the atom, negatively charged electrons were lot here in the atom. You guys were adding one more electron to this, means there exists repulsion between the electrons. Okay, already presented electrons and upcoming electrons. That means already present electrons will repulse the upcoming electrons, so that these electrons will be added here. Okay, so the distance between these two will again increases. So your anion will always have an electrons at the last part, so that the distance between the nucleus and your electrons will decreases out. So the parent, compared to parent atom, your anions will have an more ionic radius. Okay, electrons repulsion will take place here between the already present electrons in the atom and an upcoming electron. Repulsion will take place, so that this electron will move far away from your nucleus. So the distance between this outer electron and the nucleus will increases. So ionic radius obviously increases. Because of this repulsion force, exists between your adding electron and already present electrons, causes an increase in the size of an atom. So obviously your ionic radius will increase. Okay. Whereas if you consider ionic radius of cation, here cation will have a radius with less than your parent atom. Here it is more and here it is less. Right? Cations will have a less ionic radius compared to your parent atom. As that is the case of sodium. Here guys, here an atom is there. This will consist of central nucleus and an electrons, right? And I told you your nucleus is a positively charged one because the protons were adding in the nucleus, right? Your nucleus is positively charged and proton is added to your nucleus, and here the electrons were negatively charged. Okay. You guys were converting a neutral atom. That means your parent atom to an cation means you guys has to remove an electron. You guys has to remove an electron from the parent atom. For example, this electron present in the parent atom is removed. This electron present in the parent atom is removed, means there is a loss of one electron from the atom. Right? Nucleus. You have 1, 2, 3, 4, 5, 6 electron is there, means there is only the presence of 5 electrons after removal of 1 electron. So, but there is no variations from your positive charge of the nucleus. Positive charge of the nucleus will remain same here. We are removing only the negatively charged electrons. So, effective nuclear charge will be same and negative charge is removed out, so that effective nuclear charge on these electrons will be more. That means positive charge capacity on these electrons will increase because of removal of one electrons, so that the distance between, that means the attractive force between the outer electrons and the nucleus will increase. Obviously your atom will decreases its size. That means ionic radius of your cations will be less, because there is no change in the effective nuclear charge of the atom. Only we are removing an electron. That means we are reducing the negative charge of an atom, means then positive charge is same, negative charge is removed, means obviously negative charge capacity on the remaining positive charge capacity on the remaining negative charge electrons will increase. So the attractive force between those two will increase. Obviously the atomic size of your cation will decrease. So finally we got that ionic radius of this cation is decreased down. Ionic radius of this cation is decreased down. Here effective nuclear charge is same, but we are adding an extra negative charge to an nucleus or an atom, so that extra negative charge, then there is an repulsions present between this upcoming electrons and already present electrons in the atom. So there is a more repulsion, and so the electrons will add it outside, so that the distance between your nucleus and the outermost electrons increases. So ionic radius of your anions will increases. Here removing of electron takes place. Effective nuclear charge will be the same, but electrons is taking out means the capacity of positive charge on these negatively charged electrons will increases, so that attractive force increases. Attractive force increased out means size of an atom will decreases. That means your charges will develop on an atom means then you should call those atoms as an ions. If charges were developed on an atom means then you guys have to call that atom as an ions. Okay. So complete your atomic radius will decrease when an electron is removed from a neutral atom. So finally, ionic radius of cations will be less than the parent atom. Okay, this is what incomplete explanations. And one more thing is there here, guys. If the atoms consist of and same number of electrons, for example, here I will consider an ions. In these ions were consisting of an same number of electrons. For example, O minus 2, F minus, and Na plus, Mg plus 2. Okay, Mg plus 2. And in all these ions, there is a presence of 10 electrons. Okay, and these ions were considered as an isoelectronic. Okay, yeah, because the reason is what these ions will consist of 10 electrons in its atom. Okay, so these were considered as an isoelectronic. Okay, O minus 2 will have 10 electrons, F minus will have 10 electrons, Na plus 10, Mg plus 2, 10 electrons. Okay, here you know that as oxygen atomic number is 8, that means 8 number of atomic number of protons and number of electrons. Okay, electrons were also 8, right? Here next one is what? Fluorine atomic number is 9, number of protons were 9 and number of electrons were also 9. Okay, next sodium. Here guys, sodium means what? Here 11 will be the atomic number of protons were 11 and electrons were also 11. And magnesium, here magnesium will have an 12 atomic number, 12 protons and 12 electrons. Okay, and here guys, look at the charges developed on each of the atoms. Here these were atoms. When the charges were developed on these atoms means then we have to call these atoms as an ions. Okay, O is there, the charges developed is minus 2, then you guys know that minus charge is there means you have to add an electrons. Add an electron means these two numbers will remain same, only the electron number will change to a 10. Correct? You guys were adding 2 electrons means electrons number is changed to 10, but these two were common in all the things. Okay, whereas in your fluorine it consists of 9 electrons and minus 1 charge is there. That means what? You guys were adding one more electron, so 10 electrons. And sodium, here sodium it will develop some plus 1 charge. Plus 1 charge development means positive charge development means you guys has to remove an electron. That means 11 electrons is there. If you remove, then the remaining number of electrons will be 10. And in your magnesium, it will have 12 electrons and it will develop plus 2 charge. You have to remove 2 electrons. Again, the number of electrons were 10. So these ions were isoelectronic in nature. Here, guys, in this kind of the situation, which one will have an highest ionic radius and which one will have an lowest ionic radius. That is what is next concept here. And you guys know that in an anions, and we are adding an electrons means there would be an more repulsion developed between the atom. So more repulsion means what? More repulsion means less attractive force. More repulsion between the electrons. So less attractive force means atomic size. Sorry, here ionic size will increase us, so ionic radius will increase us. Okay. More repulsion you have to consider here. If number of adding electrons were more in number, then there will be more repulsion. Is it right? If number of adding electrons were more to an atom means then there exists and more repulsion. So your number of electrons were adding to an atom is more means atom is more, then the repulsion is also more. Okay, repulsion will also be more. Okay, so that if repulsion is more means then less will be the attractive force between your nucleus and the outer electrons. So ionic size increases. Finally, our ionic radius will also increases. And look out the examples here. Which one will have a more negative charge? Obviously, oxygen -2 will have a more negative charge. That means more number of electrons we are adding. That means 2 electrons we are adding. So its ionic radius is more. Then look at the next element F-. Here for fluorine we are adding only 1 electron, so that number of electrons adding will be decreased from 1 unit. So repulsion will be somewhat less and attractive force is somewhat more and ionic size will be somewhat increased, but ionic radius compared to your O-2 that will be decreasing out. So the next one is what? F-. Next comes your Na+. So here it is what? And we are removing an electrons, right? Here we are removing an electrons means electrons were removed means obviously there will the more attractive force between your nucleus and an outermost electrons. We are removing an electron, then more will be the effective nuclear charge.